What if you could peer back over 13.5 billion years to witness the birth of the first stars and galaxies? Imagine, if you will, a universe of unfathomable vastness and complexity, its distant recesses filled with celestial bodies whose light has traveled across eons of time and space to reach us. As we gaze into the cosmos, we are not just seeing space, but time itself, a window into the ancient past. But to truly comprehend the stunning depth of the universe, we need a tool capable of piercing the cosmic veil, a tool designed to reach back to the universe's earliest epochs. We need an observatory powerful enough to catch the faintest whispers of light from the dawn of time, to unravel the mysteries of our cosmic origins. Enter the James Webb Space Telescope, a technological marvel that promises to illuminate the darkest corners of our universe's history. The James Webb Space Telescope is no ordinary observatory. It's a time machine capable of capturing light from the universe's earliest days. To fully appreciate this marvel, we must first grapple with a fundamental concept: the redshift of light due to the universe's expansion. As galaxies rush away from us in all directions, the light they emit appears to stretch, to redshift, to longer wavelengths. This is where Webb's design shines. Designed as an infrared observatory, Webb is primed to detect these stretched, red-shifted wavelengths. This enables it to perceive the faint glimmers of the universe's dawn, the very first stars and galaxies that sprung to life over 13.5 billion years ago. Webb's orbit point, a staggering 1 million miles from Earth, is another crucial element of its design. At this distance, the Earth's heat doesn't interfere with the telescope's observations. This allows Webb to detect the longer infrared wavelengths that carry the secrets of the universe's infancy. But the journey doesn't end there. Once Webb captures this ancient light, it must then translate it into something we can understand. This is where its massive 21-foot, gold-coated beryllium mirror comes into play. Composed of 18 hexagonal segments, this mirror has 7 times the light-gathering area of the Hubble Space Telescope. Webb also employs a microshutter array, a grid of over 250,000 tiny programmable slits, each thinner than a human hair. This technology allows Webb to select specific objects and wavelengths of infrared light to target from across deep space. Finally, Webb uses highly reflective mirrors and advanced sensors to collect and amplify these faint signals into detailed infrared images and spectra. These images and spectra are then analyzed by scientists, providing us with a glimpse into the universe's past. With unprecedented infrared vision, Webb is poised to reveal secrets from a time almost as old as the universe itself. At the heart of the James Webb Space Telescope lies its massive, gold-coated beryllium mirror. This isn't just some ordinary mirror. It's a marvel of engineering, a testament to human ingenuity, and a key to unlocking the mysteries of the universe. Being a staggering 21 feet in diameter, this mirror is the largest ever sent into space. It's made up of 18 hexagonal segments, each precisely aligned to work as one. But why, you may ask, is the mirror coated in gold? Well, gold is highly reflective, especially of infrared light, which is precisely what the Webb telescope is designed to capture. Comparatively, the Hubble Space Telescope, our previous eye into the cosmos, has a mirror that's only about 7.5 feet in diameter. While Hubble has provided us with stunning images and groundbreaking discoveries, its mirror can gather only a fraction of the light that Webb's can. This significant increase in light-gathering capability allows the James Webb Space Telescope to peer farther into space, and therefore further back in time than ever before. Imagine being able to observe the light from the first galaxies that formed over 13.5 billion years ago, just a few 100 million years after the Big Bang. It's truly mind-boggling. However, a mirror of this size and complexity presents its own set of challenges. For one, it's too large to fit into a rocket fully assembled. So, the mirror has been ingeniously designed to fold, like the wings of a butterfly, for its journey into space. Once there, it will unfurl and align itself, a process that will be a nail-biting time for the scientists and engineers back on Earth. In the end, it all comes down to this. The larger the mirror, the more light it can gather, and the more light it can gather, the more we can discover about the universe. This giant mirror, 7 times larger than Hubble's, is Webb's key to unlocking the universe's deep past. To detect faint infrared light, the Webb telescope needs to stay extremely cold. But how do you keep something so cold amidst the blazing heat of the sun? The answer lies in the Webb's brilliantly designed 5-layer diamond-shaped sunshield. Picture this, a sunshield the size of a tennis court, each layer as thin as a human hair, but immensely powerful in its purpose. The sunshield's primary job is to protect the telescope from the heat and light of the sun, Earth, and Moon. It does this by reflecting away the heat, allowing the space between each layer to act as a thermal barrier, progressively cooling down towards the side, facing deep space. The outermost layer, facing the sun, is exposed to temperatures of around 230 degrees Fahrenheit. But the shield is so effective that the temperature drops dramatically from layer to layer. By the time we reach the innermost layer, the temperature has plummeted to a frigid minus 370 degrees Fahrenheit. That's colder than anything naturally found in space. This extreme cold is essential for the Webb telescope to function effectively. The instruments on board are designed to capture extremely faint signals of infrared light. If the telescope was warmer, its own heat would drown out the signals from the distant stars and galaxies it's trying to observe. The sunshield also blocks light from the sun, Earth, and Moon, preventing it from interfering with the observations. It's like creating a pocket of eternal night, allowing the telescope to gaze uninterrupted into the depths of the universe. The intricacies of the sunshield's design and operation are a testament to the ingenuity of the engineers who built it. It's a crucial component of the telescope, without which the mission to peer back over 13.5 billion years to the dawn of the universe would not be possible. Thanks to this sunshield, the Webb telescope can operate at temperatures colder than any place naturally found in space. It's a remarkable piece of technology, playing a vital role in our quest to unravel the mysteries of the cosmos. The Webb telescope's cutting-edge technology doesn't end with a giant mirror and a sunshield. It employs a remarkable feature known as a microshutter array. Imagine an array of tiny programmable slits, each thinner than a human hair. This grid, with over 250,000 controllable shutters, enables Webb to select specific objects and wavelengths of infrared light to target across the vast expanse of deep space. Moreover, Webb uses highly reflective, gold-coated beryllium mirrors. These mirrors are not just for show. They play a crucial role in bouncing the light that Webb captures. Coupled with advanced sensors, these mirrors collect and amplify the faintest signals from the farthest reaches of the universe. This combination of mirror reflection and sensor amplification allows Webb to transform these faint signals into detailed infrared images and spectra. With this advanced technology, Webb can capture detailed infrared images and spectra from across the depths of space. Armed with this incredible technology, what mysteries could the James Webb Space Telescope help us solve? The possibilities are as boundless as the universe itself. Let us start with the dawn of time. When did the first stars and galaxies burst into existence, piercing the complete darkness that followed the Big Bang? Current theories suggest this cosmic dawn occurred 200 million years post-Big Bang. However, these are only educated guesses. Webb, with its unrivaled power, will capture images of these earliest cosmic structures, providing us definitive answers. Next, consider the magnificent galaxies that decorate our night sky. Spirals, ellipticals, irregulars. Each one unique, each one magnificent. But how did they come to be, these cosmic masterpieces? How did they evolve over billions of years? Webb's keen infrared vision will cut through the interstellar dust, uncovering the intricate details of these galaxies. It will trace their assembly over cosmic history, revealing the secrets of their evolution. And then, there's the enigma that is dark matter. This unseen force makes up about 85% of all matter in the universe. Yet, we know so little about it. Does dark matter interact with light? Can it form structures? And most importantly, what is it? These are questions that have puzzled scientists for decades. Webb, with its advanced sensors and mirrors, could finally shine a light on this dark mystery. From the first light of the universe to the evolution of galaxies, from the unknowns of dark matter to the potential for discovering life on exoplanets, the James Webb Space Telescope is our time machine, our cosmic detective. It is our tool to delve into the past, to unravel the mysteries of the universe, to answer the questions that have puzzled humanity for millennia. The James Webb Space Telescope, our window into the universe's past, stands ready to reveal the answers that lie in the stars.